Morning, everybody. So the controls part of this workshop is going to be based on troubleshooting. And Bob and I are going to talk through some troubleshooting items. I'm going to do some of the very basic aspects of it because that's where I'm at. And Bob's going to go into the more project-based, is it project or problem-based? Project-based type application he has for his class. So he's got the really cool part. I'm just going to talk about some basic stuff and even some things that I picked up yesterday for troubleshooting that really are critical. So I'll start with that. As Keith and I were wiring up these panels yesterday all day long, and got some nice blisters on my hand from doing that, we were doing things rapidly, trying to get things done. So what does that create? Mistakes. It's going to possibly, and you'll be troubleshooting this stuff over the next day, tomorrow, it will introduce loose wiring. What's Brian Lovell always talk about wiring? One of the most common errors on BAS systems is wiring. So you'll probably find some of that, and I'll blame Keith for those. It's introducing the possibility that maybe we miswired something. You know, maybe we wouldn't put an AC on DC or DC on AC, or we flipped wires around. So there might be some bad connections that way. There might be bad connections for sensors or whatever. So just because of the fact of normal construction process, things happen that introduce issues into our control systems that have to be troubleshot. So that's a whole bunch of potential issues that you'll have to deal with over the next day. But we also have, you know, I just start listing out some different ideas. Simply just turning things on. What happens when you call IT support? First thing they ask. Yeah, did you turn is it plugged in? Is it turned on? Those simple things. Well, guess what? Those fundamentals are things that we need to follow also. We need to make sure when we have an issue to step back and look at, excuse me, look at what the problem is from the basic standpoint, and then based on those fundamentals, move up the chain to find out what the issue is. And so start listing things like turn things on. One thing I came across quite a few times this semester due to the age of our controllers in our lab is we had bad controllers. There was inputs that weren't working properly. We had the DC voltage on the inputs wasn't working on one controller, and that opened up a whole mess of troubleshooting techniques for a student who happened to have that controller. And so we can use these issues within our lab from aging equipment and et cetera, and quite often it's on the fly, to teach them some troubleshooting techniques. What are you looking for? What's the problem here? You have to define, okay, what is really happening? Why am I not seeing the digital display on my pressure sensor? And step back through that from a very basic standpoint, stepping back to, is it turned on? You know, things like that. So looking at temperature sensors, you know, if it's bad, incorrect sensor. I remember 25 years ago, working on a project, no, it's 20-some years ago, where they retrofitted an elementary school, all new controls, Johnson controls set up. And one of the teachers in the elementary school came to me after Johnson Controls had done the work, and actually they're still on site, and said, hey, it's really cold in my room first thing in the morning and really hot by the time lunchtime comes around. So I went there with her first thing in the morning, took measurements. Sure enough, it was cold. I forget what the temperature was, you know, somewhere 65 degrees, something like that. And then by time, because it was winter time, by time noon came around, it was 80 degrees in her room. So I went to where the guy was in the closet for Johnson Controls, working on the computer there, and I said, this is what's happening in that room. Check on it for me. Well, that's not right. My computer says it's 72 degrees in that room. Well, short story, they had the wrong sensor wired up to that for that room in the controller, right? So they were seeing incorrect and controlling off the incorrect temperature in the space. So those type of things for troubleshooting. Poor wiring, we already mentioned that. So scroll on down. incorrect settings, look at your dip switches on sensors and equipment to make sure that it's functioning correctly for what you have it programmed for. Program error, operator error, on-off times, all these different basic items. We need to teach them to take a look at what they've done and step back, first of all, to the fundamentals of what the controller is supposed to be doing, what that piece of equipment is supposed to be doing at that time. So the basis for all troubleshooting is falling back on your fundamentals to really start going into it. With that, Bob, I'm going to turn it over to you.
So, I'll manage it from here. Is there a way to turn those lights off? I mean, or maybe it's a lot easier to. Right behind you? Yeah, I can hit that. You think it might be a little still too bright with the windows? So I think what Ted's bringing up and what I think you need to pay attention to in any classroom environment is the physical versus the digital. And getting that spatial aptitude into people's heads is probably one of the most important things I think you can do as an educator while you're teaching your students. And I'm going to just kind of bring you through how our programming classes have went over the course of the last year and kind of give you an experience of how we troubleshoot while we're doing class. And contemporary controls is a big one, so I wanted to kind of bring that up too for our organization here, just because of the benefits that they have in regards to, what it is. Let's see, Sedona.
If I want to make one comment about that physical aspect of it, that's really important part. Making sure they start to understand not only the physical aspect of the controls, but the mechanical aspects of the building and what they're trying to control. So they give them opportunities to learn more about how the heating systems work, how the cooling system works, the air handling systems work, so they have this basis from which to build on. That's really important.
That's super important. So we ran BAS Programming 1, which was what's a controller and how do you hook two wires up to it? How do you switch stuff? And we went through and first isolated digital from analog and then started mixing them together and putting it together. Well, this is a program and I wanted to bring, this is one of the programs from one of our students. And what they had put together over the course of the semester is in the end, we tore a furnace controller out and we made the contemporary controller the furnace controller. And flame proving was the only weird type of thing, but it's something every student can relate to coming out of an HVAC program to start digesting like we did with the thermostat at the Different Best event. They understand that control strategy and it's a lot more complicated. So we wired it all up and then we had the terminations and everybody had to set their inputs and outputs based on that. But what it turned into, is one, the student didn't isolate it completely and organize it with different folders, but they started putting together an entire strategy to make it work with our contemporary controls. And this all moves from sheet to sheet just to give you an idea. But what ended up happening is we started uploading this furnace controller that was mounted in a furnace, and flame proving was held by your hand. When you saw the flame, you had to hold it. And if it blew up, it was on you. I'm just kidding. I was just scaring them all about it, right? Does it work? What do you do? How do you... But the flame proving had to make sure you could shut it off, and you had a little safety switch, like don't let the gas valve on. Like some people would wire a gas valve. I don't know if anybody's ever ran into that where a student wires power full-time to a gas valve and you get an explosion out of a furnace. Yeah, not a cool thing, right? You got to pay real close attention to that kind of stuff, and safety obviously is as fast as a gas valve getting turned off. So first we fire it without gas, and then we go into the process and open up gas if it went through that process well. So this is just a version of the contemporary stuff that you get to see how their logic got put together and fed in. And, at the end of our first semester, understanding the digital, understanding the physical, and then moving into, alarming and what happens where, when, how. And this program actually had flash codes built into it. So think about a furnace controller, and they were like, hey, we want to have a flash code. So they took an output, and they made an actual flash code happen for their alarming, just like a furnace controller board. But it's something where the control strategies are very simple. They're thermal resistive elements, right? And you can string up all the controls, operate your inducers and all your fans, and remove that furnace controller board. And it's a cool project to do. And you just grab a furnace, and then now you got a really cool end project for a beginning level BAS course, right? So questions, comments, concerns. We want this to be interactive. If you got it, or whatever else is happening. But this is something with contemporary controls that worked really well for our furnace, and they had passed through it. But it goes through this step system. They didn't even know how to put a block on a piece of paper at the beginning of the semester, right? They pulled the furnace controller out and programmed it, right? With flash codes. So they did really well in the first semester, and it opened up all their eyes. By the second semester, as that cohort went through, I think out of the 12 or 14 students, 11 of them, and I think they're all hired now by different BAS companies. They just came in and swooped them all up. It was over in a second. And we'll start seeing that again and again and again.
Bob, can you take one step back?
Sure.
And just explain the type of software they're looking at, the type of programming they're looking at quickly?
So if anybody doesn't have it, and I hope you get into it, Contemporary Controls, we work closely with them, and they help us in education. They developed an emulator, so students can go home, obviously, and program at home. And you don't need to have a controller at home, but you can buy them, and they're affordable. And when you think about a textbook at $300 a crack, you know, I think students can get controllers or at least a Raspberry Pi for under $100, you know, so they have something to work with at home as part of a class. But Contemporary is inexpensive, software's free. They have a lot of other pieces to get education on, because in any BAS or programming class, if you can't establish communication, that's probably, networking is probably one of the most important things, as much as I can't stand IT departments. Is Robert in here? I'm just kidding. No, but you have to get them to start understanding, to think through a networking lens. And that digital construct in the student's mind is very difficult to make headway through, to get people to think digitally. And again, there's the thinking digitally, and then there's the physical. And then where are your points located? And what's the spatial aptitude? Yes?
You mentioned Raspberry Pi. How does that fit in?
They have a small, simple controller. It snaps on the top of a Raspberry Pi, and you can do the same type of programming with it. Yeah, and it's fairly inexpensive. So there's different ways to do it. We got walls of controllers and all kinds of stuff. So what we have them do is emulator at home. They come in, and I at least get to monitor before they want to blow up a controller or something, right? I mean, the most destructive force on this planet, as we all know, are students. And there's no such thing as student-proof. There's only student-resistant, right? Okay?
Did you,
Yes.
did you give them the order operations, or did they have to come up with their own?
We went through a basic sequence of operations, yes. And we had to go through it, and they had to follow those guidelines. And I think it was a standard 80% of furnace that we went through, and it's good to go. Is that what you were asking?
I kind of failed in my initial discussion here. The intent of this whole discussion is Bob and I are just presenting some ideas and things. Then we want to open up for everybody, or as we're talking, to bring your own concepts, your own labs that you've done on troubleshooting as part of the discussion, so everybody can learn from everybody.
And everybody in HVAC programs, we all understand how a furnace is supposed to fire. So it's a real control strategy and sequence of operations that everybody can relate to. And you can use all your prerequisite knowledge to understand this. So when somebody uploads their program, now here's the test. This is, can you run your program on this furnace and it doesn't, an inducer doesn't come on? Well, what's the problem? How are you going to go forward? You're going to go backwards? And then you smack them mentally as hard as you can, you know, and let them know, what's the problem? What's the problem? Say it. You know, Sam Kinnis, I'm just kidding. I do that. But, you know, you get in their face and make them what I like to call think. And when that starts happening, sky's the limit. Then they can program a furnace at the end. But you start with, okay, I want to bring a thermistor in, right? It's steps to get to the furnace world. You have to step them. You have to step them digitally, you know, opens and closes and verifying, is this working in communication? And then you move through an analog perspective and start bringing in analog stuff. And then you got to weave it all together. And I have these huge story problems that I write for them. And they got to get them right. If they don't, I just yell at them until they do, and it works. It seems to work for me. So, you know, whatever, just sharing it with you. So I think it's very important. And then, you know, we were just talking about this, that nobody has anything figured out, and they don't. You know, I mean, obviously automation and stuff, it's 70s, it's less than 100 years old. This is new stuff. I tell all the students, you know how we used to have air conditioners when I was a kid? We'd open the window, you know? So it's all changed, right? But this is an open architecture program that can connect to the Bass View that we got last year here in the summer, and that's where you can put your sizzle on your steak, as George would say, who's the president of Contemporary Controls. He's a really cool guy. Him and Bennett, they come in and they work with us on this, and they host training for contemporary controllers. If educators want to come to a training, we can set it up over at COD and then just bring a group of us there. If you guys want to come, and we could do a whole class on the routers, on all that stuff, whenever you want. Well, as long as I'm not at the cabin. But other than that, be A-okay. Be A-okay. I just wanted to give you a flavor for some of the projects, and the troubleshooting really comes into when it doesn't work. And one of my favorite things for any student is failure. So that's how you learn, right? You got to fail. And watching them fail and then getting to think through their failures is, I think, the most valuable success tool that every one of them are going to have for their future. And we had a great time with that. Another one, so they transition into this. To be honest with you, I didn't know how any of these classes were going to go or what was going to happen, but I just knew we had to go walk down that road. So we had BAS programming too, and we had students step into that. And that was a closed architecture. So we used the UT platform, or ALC, or whatever you guys want to call it, Icon, because we have a ton of that stuff. And that's different because we're playing with licenses now, right? And there's all these other requirements. And we'll talk about stuff tomorrow at Train that I've been working on nationally, trying to get us some traction a lot of different ways with a big closed architecture licensing type organization, a big box automation company. But BAS programming 2 was kind of like 1. But now I sent them down to the lab, and they had to go dig through all the sensors on a cooling tower, figure it out, and then they had to write out all the points. And where were they? Were they binary? Were they analog? Or is it inputs? Is it an output? What do we need for alarming? How do they do it? And first they create their points list. And then we talk about a sequence of operations and how it's got to be managed. But the most important thing to get them to start thinking is, where does this need to be housed? Because they need to understand that that point is not just virtual. We're not playing in digital virtual land anymore, imagination land, or whatever you want to call it. It physically has to tie to a controller somewhere, and there's limitations to the amount of points it can take. And getting them to understand that was one of the discoveries, I think, that I could share with you about troubleshooting and working through a problem, is to understand that connection is the most critical thing I saw in a student. Is where does it terminate physically, but where does it need to be used digitally? And starting to organize your thoughts like that is just, it's an experience you have to go through. Like snowmobiling in northern Wisconsin. I'm just kidding. Shameless plug there for me. No, I'm just kidding. Go on. But so Icon. So we had them do an air handler. Our trained air handler. This is what a student came up with. And how they went through it and how they tied this all together. We have air handlers. We have a VAV system now that can bounce as just a straight air handler with a constant volume, or we have a VAV system. We just added a ton of VAVs to this thing, so we can manage and control it a lot of different ways. But they physically get to go down to the lab. They look at all these points, and they start putting them together. So I don't give them templates. This isn't a template. I won't allow them to use templates. Why? Because it stifles creativity. I throw that, I'll be nice in the video. I throw that stuff out the window because I want them to creatively think about issues. And it's really fun, especially the students that want every little point or just know-it-alls or whatever else. How you torture them effectively is you just tell them that they didn't have the titles in the right spot, or the boxes weren't even and they didn't line up. And you play with the aesthetics. I mean, there's so many different ways to have fun with it. But you sit down with each of the students and how we troubleshoot it. And I have a couple of examples, and I'll go through with this air handler. But you take the students, and the experience then becomes a facilitation together through the train wreck of their brains. Is a nice way to say it, right? And what I mean by that is that everybody that programs has a different thought about how a different block is going to work. And how you develop that thought through their mind is kind of like that facilitation or Socratic kind of building automation way of looking at things. So I'd sit in the front row and we'd pull them up on the big screen, room gets dark, and we look at each group's work. And I'd let them work in pairs at first, to kick it back and forth and a little bit of talking, but no copying. I see that copy and I started yelling. And they started working through a problem together, but then they would run into, they thought it'd work one way, but what was really going to happen when we turn this system on, right? Is that fan going to cycle? Is it going to go on and off constantly? To bang bang theory is what that's called in electronics, bang bang theory. What you were explaining earlier, Peter, when that building goes on and off. And they start to see how the fans aren't running with their PID loops, and they start to realize the physical problems that were created by their digital disaster, and getting them to think through how to solve their problem is probably the most significant gain we had in their minds, but to do it on their own and to organize their thoughts. And an ALC, this is a fairly simple way to organize it with boxes and where we put it. And if you're going to troubleshoot the system through the whole way, you need to organize yourself and label and pay attention to details like that and organize your thoughts together so that if there is a problem, you can go back and fix it as opposed to having a mess of blocks. And that becomes a very good exercise for their minds as well. So each group would get up and they'd present, and I'd go through, and it's not easy to facilitate that class because you have to understand the train wreck and what's going to happen with the logic. Okay?
Of 6 different groups.
Yes, of 6 different groups. And anybody wants any of these kind of things, you guys can all see the programs. These are the programs that are going to run our whole central plant that we've been working on for 7-8 years. And they're ready to be uploaded. We've moved stuff. We've shifted it around. But we have a living, breathing central plant that they're programming now, and not from like a train isn't programming the chiller strategy or the refrigeration. Every strategy will be programmed by our students. Every strategy. There are no templates. There will be none of that. And then we'll develop graphics within it and then troubleshooting methodologies. The other thing is the network architectures that we try to create is a tool to give them a crash course throughout the entirety of building automation to understand how to dance through routers and get subnetting and understand how you're isolating different networks from destroying the bandwidth for your IT department that they always complain about anyway. So there's a lot of different elements there, and there's a lot of cool opportunities with each group creating that digital disaster that you then talk through, not just with them, but the whole class learns at the same time through every problem that was created that doesn't work. And you just kind of walk them through the part that way. It's worked really well. And then we move on to commissioning and then integration in the next couple of steps of classes. But I've kind of figured it out because finding a BAS teacher is probably one of the most difficult things to do. So first we're laying it out, getting groundwork. You develop your students. You find students that are successful in industry now, and then I bring them back in, and then they become teachers. And that's probably the most effective way to teach this. And throughout the process, you explain, and I liked what Ted was saying earlier, this is our trained air handler. There's different set points. This is all built by a student. This is last semester. What's going on here in this ALC program? Hold on, let me pull one more up.
I just mentioned too, Bob said about your students being the best source for good instructors in the future. You gotta plant those seeds when they're your students. If you see somebody that has good potential, I did that with one of my students back 6 years ago. Now he's teaching at our college.
It's 3/4 of our adjuncts.
Yeah, 3/4 of our adjuncts and Terry are former students. They know the way. That's what it's about. That's what it's about. So Here's another one. Oh, speaking of IT people, you know, you have to be able to manage that. It's pretty fascinating. But in this one is a student development for our chill water plant design. So this will all have graphics attached to it as we get into the commissioning process and making front end stuff. But you know, we have different pumps on everything, and every one you see here is just ons and offs, and you know, evaporator pumps, pump 1, pump 2, and it gets, I mean, you can see it's pretty complicated where it goes, but there's all these network points that we're dragging across that have to coincide and work with them to teach them how to pull all this stuff together. But, you know, it looks complicated. So you start doing it with the class, you just sit down and do it with them and figure it out and go through this stuff, and you'd be amazed at what the capabilities of students are and their resilience to, you know, their failures and how they work around it and how they work together to troubleshoot these complicated problems that they're creating in their own mind. And I don't solve their problems on purpose at all, because the greatest way to learn how to listen is through frustration. And until their brain engages in that frustration, I don't think they're as receptive. So I like pushing them to the limit, and I won't give them answers. And I think that's a fascinating way to go about this. And if you got questions, I'd be happy to answer them.
The
Yeah.
process works.
Process works. Meetings will continue until the process works.
So do you guys have anybody have an example type of troubleshooting lab or experience they have from their college?
And all of this stuff, here's one of the things I was thinking about, some of these things, is it's interesting and it's so hard to find teachers or what is happening. But, you know, they talk about this OER stuff, right? Open Educational Resources, right? OER is a thing. It's almost like we need to have a best OER where we can get a class, make it accredited. And if there's a class that might not work with an instructor where you could do it, if there's a way to virtualize it or go through some stuff and have a resource to develop, this is the kind of stuff I want to do, is help people learn how to walk through things like this and program it and, you know, just think digitally and pull it all together and make stuff start on fire like Robert's going to do later with that refrigerant. All right? So,
Bob, does your students go in and wire up
yes,
all the controls and stuff?
yeah, everything. Yeah, and I'm not saying stuff gets blown up a lot too.
Yeah,
There you go. You got to be real. The hardest thing in robotics labs are suffering across the nation, everywhere else. They blow those servos up all the time because the wiring, you can't catch everything. And one of the number one things to mitigate destruction, especially like in our facility electric class or having these prerequisite things, is standardization and wiring. So when you're playing with, forget the students. So an instructor can wrap their head around, okay, all three-phase power's in yellow for us, all, you know, this is in this color, and all dry contacts are in thermostat wire or whatever it be, but you create standards that all students have to follow, or they have to tear it down, start over, I don't care. And they start that whiny stuff, I just pull all their wires out and make them start over and be like, what? You're failing right now. Get to work.
In my lab, small college, so I don't have
Sure.
equipment and stuff.
But you have a furnace.
Yeah.
That was my point earlier.
I got a furnace, I think.
Yeah.
Justin came up and seen it, and we got a small duct system coming out of it.
Yeah.
And the project I had them to do is I use two controllers. Okay, one controls the Siemens Talon TC20. They have to learn how to line program that, and they go in line.
I mean,
That,
I know.
they like it better than the block program. Some of them do. But they go in and program it. Then they had to go in, and I used the Kelly catalog.
Oh yeah.
And I got different sensors in the, in my classroom. They have to go pick out the certain sensors that they don't use. Okay, and they have to know if it's type 3
Yeah.
type 2 whatever, and when they're programming it in, then they have to go out and wire it up. They have to go through and check all their points and stuff, and then they put their controller on, wire it up to the controller.
And that's what I was referring to as the physical.
Yeah.
Right? If you don't teach them the physical and they never experience it, a lot of things get burnt up. Yeah.
And then then they take that controller out, then they do the EDIO controller that we have. They program the EDIO controller to the same sequence that
Yeah.
that I put out there. And they have to know what sensors, how they control their dampers. It's going to be direct open, it's going to be modulating
Yeah.
dampers and stuff like that. And so if they've got something that's not working correct, they got to go in there and troubleshoot that portion.
Yeah, you don't have to have
You don't
all
have to
kinds of
be-
stuff, nothing. Yeah, that's exactly it. But establishing that baseline, I think, is super important.
I really like the furnace too because it's manageable throughout a semester, right? They can take the order of operations, they can build and design everything they want to for that controller. They can wire it up and they can commission it. When I learned this stuff, like the class, it was an entire building. It was a fake college, right? So number one, there's nothing real that we got to connect to. Number two, we couldn't commission an entire college in a semester, right? So they get to go through that whole process, and in that commissioning process, the problem show because we've all been there. I mean, even with simple math, right, where you're 100% sure of what you got, and then you realize it doesn't work. Well, that's that commissioning process, and that's when the light bulbs start going off because they have a lot of confidence when they're installing that program, that control.
Perfect time to stomp it all out, too.
Yeah, it's through those basics. Some of the most simple things.
Yeah, and when you've got those basics, you can do a whole canvas, right?
Exactly.
But if you don't have those basics on that furnace, you're not going anywhere.
And we see a lot of apprehension to take jobs because they think a beginning level technician has to be like this complicated thing like this or something. I'm like, you guys, this is way beyond what you're ever gonna need for stroking a VAV box. That's what it comes down to. And then they start to realize it, and you have to dismantle or disillusion them from the complexity of the apprentice BAS technician. And that creates that apprehension that doesn't allow them to even think about applying for a job. We just started working with Schneider, was trying to hire everybody. Sizerco, another huge one. Train, Siemens, Automated Logic, UT. Contemporary is still hiring people to work on the inside to develop. And so there's a million different companies that we're working with. Siemens shows up. We have our ex-students have migrated over there and like, hey, Bob, we need more students. Well, of course, everybody does. Now, you guys are always going to get the line, right? We want your best and your brightest. No kidding. That's what everybody says. But
how many of our students have come back too and said like, oh, the lead, like they were so apprehensive to go out and get this job, right? They want to get their certificate, their degree. They want to get all this other knowledge before they go out there. And how many come back and say, oh, my lead tech didn't even know how to do this stuff. I had to show them.
exactly.
I'm not joking.
Fast.
It's constantly.
It's like that.
Constantly.
Yeah, we get that. So it's a fun process, and you know what? It's an enjoyable class. You know, it gets kind of boring though. You know, for the programming, because if they're working on it, you want to be up there just torturing them the whole time, but you know you can't. So you know, you gotta think of other things. So here's what else I've thought of, and how you stage it is when you're teaching a BAS Programming 1, your cohort that's moved through, I'm going to have them roll independent studies on top of our classes that want to finish their degree so they can spend the time with us and I can still answer those same questions in the class, and then I move them into the lab environment and they can progress towards their completion, which is huge for, obviously, you know, the administration part of these things, right? But also for their success in the future and their degree and certificates, right? Because how do you teach all the classes and then do HVAC in addition? You have to get creative with how you stack and stage and develop that classroom environment for everybody to have an opportunity to finish. Real equity.
Anybody else have some example from what they do?
I have a question about the first one. Does the first, and stupid questions are always welcome at these.
Yeah.
Yeah. Sure
Does
you
the,
can.
does the furnace come with a sequence of operation? Or you work with? Okay.
Yeah, well, we just have it written out. I just send you. It's easy. Every furnace is about the same.
Every furnace has a sequence of operations.
Yeah. Combustion. If you got an 80% or if you have a 95, it doesn't matter. It's just a matter of taking over. You know, they all think they're like proprietary. It's all the same garbage, just put in a box a different way. It's okay. You know, like you could just take it all over. And that's my favorite thing to do is show them that you're your only limitation, right? You're your only limitation when you believe that that somebody else created this, that somehow they're substantially smarter than you. And getting them to believe beyond that is what I think makes the greatest technician, to have faith in their ability to create and integrate and design, and they're going to be powerhouses. That's what it's going to be.
So I also teach the electrical HVAC in my classes, so they can't take the BAS until they've taken all the electrical, because that's kind of where
It's a compliment, prereq, yeah.
Yeah, it's a prereq for us, and yeah, and it helps out a lot. And the way I build my electrical class is kind of the same thing you're doing, is we're working with a lot of relays, thermostats, and kind of building their own thing.
Drives, yeah.
Right?
Yeah.
So in their brain, they're like, oh, you could create your own and understand it, you know. But of course, I teach them to read the schematics too, so you know if someone's messed around with a unit.
Yeah.
Because if you can't look at it, you're like, wait, why is it all different? Or what is this extra component? That wasn't in the schematic. Right? So
Yeah.
you could read someone. So that's pretty much how we do it, is that we hit hard in the electrical, the prereq classes, and then once they're in there, then it's a little bit easier, but now they're trying to convert their brain into that programming side now, right? Because you're saying the physical and the
Yeah,
programming.
physical and the digital, yeah. Yeah, that's an awesome lesson to take them through.
Yeah.
Not easy though, not easy.
Yeah. Oh,
A lot of trade
so many-
mix.
That's why I try to get rid of breaking the cheaper components, right? The electric.
Yeah,
Break
they
my
don't have
relay, break my contact.
Yeah.
All right, that's fine. Break my little transformer.
they don't have faith in their electrical diagrams, which is the answer to them all. So one of my things I always yell at them is like, we don't train people for hope electricity. Because I hope it works. Right? No, you believe in that diagram. That's what we train for, not hope electricity. So I always tell them when they screw up, and I see it. Because you get some of them, they're like, oh yeah, that's the diagram. And they start doing the wires like Ricky Bobby, you know, with his hands when he's trying to figure it out. Like, plugging it in places. And you got to really watch them, right? And,
But they're looking at you for the answer.
yeah, they're like,
You gonna respond? Like,
yeah.
this here?
No.
Like, nope, we're gonna smoke the
Wrong.
transformer today.
Yeah.
I have one story because I would draw like a diagram and tell them wire on the board.
Yep.
And what's funny is one student took pictures and was like, I could do it. And the next day I drew a different one and wired it the same way. Look, I wired it the one. It was like, no, that was from last time.
It's new. Yeah.
I was like, you took a picture of it, huh?
We got an exercise called the IT people of the world, or the digital electronics folks, always ruin, the languages of what a common stands for in control wiring is completely different than what it stands for in a residential electricity environment. And there's an exercise called the common problem, which there is no solution for, to get them to understand good wiring habits through a relay and utilize in its full potential. But it's made until they recognize that it's impossible to do it correctly through their failure, that they finally rise again and understand electricity at a different level, like that. It's called a common problem. And it's really important for controls electricians to understand that, so they get away from that basic, me use one relay for one thing. Utilize the whole relay. And we do it in our refrigeration class. Again, it's a culture of electricity in all the classes you have to train on again and again, because running through the ropes one time, in like a football practice, doesn't get it done. It's again and again and again. And it's what it is. It's repetition, it's experience, reps on everything. That's with everything in HVAC programs.
Yeah, we also implement a program that for the students to find a job right away in the field, but hopefully they do still keep taking our classes. But we partnered up with other contractors too. The promise is they'll at least let them take the class every semester. Right? So either Monday, Wednesday, or Tuesday, Thursday, whichever they do, because I see students that are on the field actually learning a lot quicker. Right? Because your repetition, like they'll learn. Like one of my students was working with a residential company, and they're installing a lot of furnaces. And now he was working there for a year and he decided to go back to school. And now he understands why he's doing certain things, not just wire that green one to that one. You're like, okay, and now he understands what that green wire is now, right? Or,
Yeah, we get that, or they recover into buckets of water, stories from
oh,
students.
yeah. That's
Well, you see all the practices, all the different ways, but there's no question that doing it during a day is not super helpful.
Well, one story is one of my students actually, he was, when he got in the company, they started him off at $17 an hour, but then he was outshining all the journeymen that was in there. So, before even his 6 months, he got like a $15 raise right away.
Yep. Oh yeah.
Yeah.
Well, you pay or you move, and you got to hold the line. It's a hard line. I think ethically, an instructor has to hold the line of, if they're not treating you well, I'm not here to train just for your organization. It's for the entire community, the industry. That's on you. Don't ever come at me. I don't let any employers come and talk to me about that with students, but I let them know this is a typical starting wage and this is where it is. And, if you're just in for a paper mill to create, technicians so you can keep printing money, no, I'm not into that. I'm into, we need real technicians for the community that understand ethically, they have a right to a greater wage if their skill sets merit it.
Yeah, they have, like he was saying, that the lead technician just got fired and now he's the lead one.
Yeah.
And you're going to school.
Right?
Yeah, so it just shows.
Some people shine, some people it takes them a little bit, but that's our job, right? It's everybody. We serve the whole community.
So it's a great story for him, like, 'cause he took that. A lot of our students like, no, I want to take the $20 per hour right away. It's like, no, sometimes you just gotta start low, but he started at 17. But he has a lot of wrenching experience. He could build a car, like the back of his hand, right? So
He's already a technician, yeah.
Yeah, and when he started with being a tech, he picks it up real quick. And when he was going to school, he picks up more of the theory side of things.
So it sounds like you got a future teacher for you then, an
Oh
admin.
yeah, I told him he is interested in that too. I told him, like, if you want to come back, the door's always open. So yeah, and now, like I said, he's a lead technician for that small residential company now.
Everybody in here's got them stories.
17 to like 30 something already, and that's less than 6 months for him. Just
Yep.
because he knew what he was doing, and some of his tech kept messing up and all that, doesn't know what to do.
Well, any other building automation adventures for anyone? I can't wait to hear Jen's. It's gonna be good. Any other energy adventures? Where is it at? Building automation, energy, classroom environments, labs too. We have a lot of different new trainers that we've been building. So I don't know. I don't know if you guys are coming out to Chicago at some point, but I'll share whatever with you. And even the designs, if you guys have Blackboard, we have, I'm using Blackboard. I got core shells built for this stuff, and they're developing now. So,
Yeah, I'm interested in that field of training and all that. I'll give him a tip.
we have education, training, anybody can do.
That's what I mentioned about the energy aspect. So with what I've been doing in our curriculum is trying to get a real life experience for them. So, because we don't have the nice lab that you have. So we've been coordinating with our operations department this past year to work on the heating system for the whole campus. Because we saw a problem, and bringing that problem into the classroom was really great for giving them thoughts on just how mechanical systems work, because it's all hot water system.
Sure.
They installed condensing boilers a number of years back, and we didn't see the energy savings. So that was the whole premise. We used it in our M&E class, our energy auditing class, and then this past spring, our commissioning class, to troubleshoot the system to find out why isn't it saving the energy. And of course, the answer is because they put condensing boilers in, but didn't bother to think about how condensing boilers are most efficient. Get that return water as low as possible. That's what it bothered me. So,
Well, and you have to understand friction loss and pump head and how pumps work and motor efficiency.
It's just, there's just so many problems before you get there.
We just did a training for Service Logic. It was one of the groups that, and maybe one of these other seminars bring them in nationally, but Service Logic, probably in the top 3 to 5 biggest mechanical contractors in the country. and they're now going to be training at our lab 2, 3 times, 4 times a year. And we just finished a hydronics one where their existing incumbent workers, flew in from all over the country to learn hydronics. And it was awesome. It was awesome. I had a great group, like 20 people in there from all over the nation. And it's just going to keep compounding. And it's going to be a whole training system for them. But, the prerequisite knowledge to understand an energy is more vital than anything else because, we're not counting light bulbs anymore. We got to look at the mechanical systems that folks don't understand in order to find those simple yet complicated things to understand. And what Ted's saying, this program here, there was an entire diagram that we went through on the wall of how the central plant is set up and how it was physically diagrammed so that the students could see, oh, this is a chiller, this is a pump that attaches to it, this is what starts to happen, and build those blocks in their mind before they started programming with blocks.
And you actually were able to take them physically to
Yes.
where those are located. And that makes a huge difference because.
But I think you can do it with I think you could do it with a good board drawing and discussion. I think you can get through it, but it's not the same as seeing it. It's not at all. But you can give them an example with your existing structures, and you guys have a huge lab.
Yeah.
That's built. I mean, you have an awesome central plant. So, is that pump still rattling and cavitating? I'm just kidding.
Yes. It is.
See, I don't forget.
I've walked away from that.
I want to say, if you're going to approach your facilities about their equipment, watch how you approach them, because approach them and be like, we're going to fix your stuff. They don't like that.
No, they don't like that. I approach it with my facilities that, we have a class, it's really good for them, for the student experience to have real life examples of this. So let's interact with this. We have time to work on this. You don't. You have knowledge that we don't have. Let's share so that the students can be better for it.
And
Try to push that angle. It seems to work a lot better.
Well, I
Go ahead,
mean, working with facilities, because, some of the facilities, the people are gonna retire and they need to be replaced, right? So, like the head of my facilities, he's always asking me, hey, you have more HVAC people, They constantly, our school keeps on growing more and more campuses, but,
Yeah.
so we need more maintenance people. So,
Yeah.
and exposing them and working together with your facilities,
That's the other thing we're trying to do. We got one person into our facilities, but he's retiring right about now. And so I need somebody else in there from our.
so
Well, Ted, I seem to recall for a while you were locked out of everything. And now you seem to be back.
Yeah, they didn't want us in for a while. I still need to call them to let me into spaces, but it's just a matter of calling them. No problem.
so
Is there a change in leadership?
There's a constant change in leadership. And I've got that going on right now, so we'll see what that next transition looks like.
there's always department politics, but today's Tuesday. Tomorrow, we'll go over my political spearhead project. We'll talk about that and how to manage your facilities department, but that's another story. The other thing I wanted to tell you about Terry has ran these millionaires buildings for years, and we pulled them finally over. So if you ever have any want to understand, his whole building was set up with heat pumps. And it was a system back in the 70s put together when nuke power first came out and everybody thought things were going to be super cheap.
Huge discounts on electricity.
His entire building was heat pumps, and you had to heat, obviously, the loop with boilers, electric boilers, mind you, and he'd always be doing different control strategies and on the phone with them about stuff.
I literally changed I just come up with new ideas to try and change the strategies.
It's airflow, and there's pipes through the walls backwards and stuff that people would get wrong. Just stuff everywhere. So if you want to have a conversation later on or something about heat pump stuff, or you want to know some more things about it, because I know a lot of folks in here are interested in those kind of things, here's your resource.
One more example on that facility. We back around 2012, Joe Jacobson installed a geothermal heat pump system where that pump is that you mentioned, and we also at the same time installed a solar hot water heating system on campus heating all of domestic water. Well, that hasn't been working for years. And I said, well, can we commission it? I mean, we can't hurt it anymore, in fact, it's not working already, right? So we commissioned that a year ago spring. We actually got it back up and running, and it's still working today, thanks to our students doing it for them, and they had no hands-on experience with it at all. And we did develop training videos and stuff for them to use, but they haven't used it yet. But those experiences are invaluable for the students, because they go, hey, I actually worked on something, and we got them to change something, and we had impact. So,
You know, on top of that, students, you know, come into the programs, I mean, they lack confidence, but when they do stuff like that, it builds their confidence. And as they get more experience doing things, they get more confidence and then they become better technicians.
and I work with the students too, and I say, well, you know, what you understand about this system is more than any of the people running these buildings on campus know now. And so, while they know things that you don't know, you know things they don't know, that helps that confidence boost, right? So it's really important to give them that experience.
And you get to know your building structure. We had our automotive lab. It was a brand new, LEED building, blah, 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 that. But they had the automotive lab. Every time the instructors would talk, the unit heaters would turn on, brrr, over them. And they're like, why is this unit heater always on? Everything's working fine, on the laptop and everything's good. But sometimes it's as simple, and Ted was saying this earlier, sometimes it's as simple as I just walked in there one day. It's been running like this for 7 years, right? Seven years, LEED building, right? And we go in there, and they already lost the condensing boilers because they didn't know how to run them. They rotted out, destroyed, whatever. Another story, another day. But I go into the auto lab, and there's perimeter loops everywhere. And all the valves are backwards. So it's something as simple as not setting up your inputs correctly, where they could just reverse them digitally. Then they opened up, right? And all of a sudden, the unit heaters didn't turn on every 2 seconds in the automotive lab. And it was something as a basic valve position that indicates to anybody's mind. And they had problems for 7 years before I got there to do this. And then they fixed it. The fascinating part about it is that the company that came in to change out all of the controls read the original specs, programmed the whole thing, and it's doing the same thing again. After they had fixed it, me just do like papers say, And it's not that they don't know, but they don't know. And commissioning is only as good as the commissioner. And that's probably the best example that you can give students an understanding that there's nobody that's perfect out there. Controls companies create disasters everywhere. It's just most folks need to understand that we're trying to train technicians to elevate that level of success in buildings, but if you just know wiring and digital logic, you might not understand airflow or how water flows in a pump, or how refrigerant moves through a system, or temperature differential, or pressure differential. Those are the things that they need, those fundamentals to be effective technicians, I think.
Yeah, and it kind of segue, moving on to the next part of this, but that very concept of not just focusing on one thing or knowing just one thing is the basis for HPBOP. Having a broader breadth of what you're looking at and how you're trying to drive the building.
Exactly.
So, any last comment, question, before we move on to the next?
Talking about troubleshooting, if you don't know what it's supposed to do, how are you supposed to troubleshoot it, right?
Yeah, exactly.
And how do you learn what it's supposed to do? You commission equipment. Like, it's cyclical.
Yep.
That's how I look at it.
So I think with that, we're going to move on to the next segment.